Okay, we'll look at some of the homework problems that are in section 12.3, and there's only going to be two problems that we're going to be looking at. One would be a problem similar to this. In the parallelogram shown, find x. In this case, we're trying to find the length of x, which is I'm going to mark off right here. That's that length that I've darkened in black. Okay, we know that the opposite sides are going to be congruent in this parallelogram. We know that this length is 10 inches, and from this length to this length on the end has a measure of 8. So that means that this measure right here has a measure of 2 inches. Okay, now that we know what this length is, I can find out what x is going to be, because I know from the left to this part right here to the end, just to this part where I have my tip of my marker, that's 8 inches. And I know this part is 2. So if I subtract 2 from 8, that length, which is what x is going to be, will be 6 inches. So here the length of x will be 6 inches. All right, that's how we will do problem number 1. All right, and then problem number 2 is this. Some car jacks are constructed like a collapsed rhombus. When used to raise a car, the rhombus is easily seen. If the sides of the rhombus are 12 inches, what is the maximum length of the shaft? Okay, here we have a car jack where you can see that the rhombus is just easily seen here, that this length is going to be 12, and that length is 12, and that length is 12, and the other one is 12. So, if we were to collapse this rhombus, the maximum length, since this is 12 inches here, and that's 12 inches, if we were to collapse this as flat as we can, then we'll have 12 plus 12, which will be 24 inches. So the maximum length is going to be approximately 24 inches.